In question number 5, a manufacturer manufactures two types of steel. So two types are A and B, right? And there are two type of machines he is using. One is automatic machine and another is handheld machine, hand operated machine. So it takes 4 minutes on the automatic and 6 minutes on the hand operated machine to manufacture packages of screw A. So let X packages are made of type A and Y packages of type B. And how much time is it taking on automatic machine? 6 minutes, sorry, 4 minutes on automatic and 6 minutes on this. So this is 4x and this is 6x, right? So another one is for package B, 6 minutes on automatic and 3 minutes on hand operated. Now it says each machine is available for 4 hours. Here we are taking time in minutes and time. This is given in 4 hours. So this will be less than equal to 240 minutes. This is also less than equal to 240 minutes. So what are the conditions coming? 4x plus 6y less than equal to 240 and here 6x plus 3y less than equal to 240 and xy are positive, right? This is the condition for the plotting of the lines. Then assuming that he can sell all the screws he manufactured, how many packages of each type should be factory owner produce in a day in order to maximize his profit? What is the profit Z? That is makes a profit of rupees 7. So 7x and 10y. So this is your optimizing function. And then you have to find the profit also. This is question number 5 equations. Next one is question number 6. Question number 6 is a cottage industry manufacture pedestal lamp, and I think this is the same as the previous one. So you can try by yourself this question. We have tried 2 or 3 questions, so you can try to make. If there is any doubt, you can ask me. Next, question number 7. There are 5 minutes of cutting, 10 minutes of assembling. So this is also the same type we have done of the screws. So please try this also. Now, question number 8. If you see question number 8, a merchant plans to sell 2 types of personal computer, a desktop. So this now 2 types of computers are desktop and portable. Then he estimates the total monthly demand of the computer will not exceed 250 units. Determine the number of units he sells of each type of computer for which the merchant should stock to get the maximum profit. He doesn't want to invest more than 70 lakh rupees, and if his profit on this is this much, on desktop is profit this much, and so let us the X number of desktop and Y number of portable computers. Now the cost is 2500 into X. That much he will invest on desktop computers, and 40,000 into Y he will invest in uh, portable computers. And how much investment he wants to do? 70 lakhs. So that should be less than or equal to 70 lakhs. Right? So one equation is this. Second equation you are getting from here. Total monthly demand means X plus Y will not exceed, means less than equal to 250. X, Y are positive. And what will be the Z function? Z function is on the profit. Z is equal to 4500X plus 5000 Y. Right? So you have to maximize the profit. So you have to find the maximum value of this. Next, this is food type again, vitamins and minerals. So please try this also. Question number 10, I am doing, there are two types of fertilizers, F1 and F2. It consists of nitrogen and phosphoric acid. So how much is nitrogen? F1 consists of 10% of, so let this be X kg and this will be Y kg. 10% of X is nitrogen and 6% of X is phosphoric acid. F2 contains 5% of Y as nitrogen and 10% of Y as phosphoric acid. After the testing the soil condition, a farmer finds that the she needs at least 14 kg of nitrogen and 14 kg of phosphoric acid for his crop. So this is at least means it should be greater than or equal to this 14 kg of nitrogen and 14 kg of phosphoric acid. So what are you getting from here? 10x plus 5y, that is greater than equal to 1400. First condition. X, Y are positive from here because kg can't be negative. And second one is 6x plus 10y, that is greater than equal to 1400. I have taken the LCM. So these are the two conditions. And what will be the objective function? Cost. 6x plus 5y. Cost should be minimum, no? Minimum. So you have to find the minimum objective function. So the objective function is this. You have to minimize it using the LP. This is your equation first. Next one is transportation problem. There are two factories located at one at place P and another at place Q. From these locations, there are three stores where they will supply the products, goods. So this is your place P, this is your place Q, and these are A, B, C. Now, the weekly requirements of the depot are 5, 5, and 4 of the commodity, while the production capacity of this is producing 8 units, P, and Q is producing 6 units, and this requires 5 units. This also requires 5 units, and this requires 4 units. The cost of transportation is this. How many units should be transported? So, first let us assume that P is supplying X units to A, and X should be positive. If A is taking 5 units from P, so it will take 5 minus X from B, na? Q. From Q, it will take. These are the two depots who will supply the product to these three stores. The ABC are the stores, PQ are the depots. So if P is supplying X units to A, then because total consumption is 5 units only, so it will take 5 minus X from Q. Same. If P is supplying Y units to B, Y should be positive. Then it will be taking 5 minus Y from Q because total requirement is 5. Now, out of 8 units, X and Y are given over here. So how much is left with P? 8 minus X plus Y. Na? So that only he can supply to the C. So total is 4 and 8 minus X plus Y is supplied by P. Either you take from the Q side or from the C side, one of the same thing is there. 4 minus 8 minus x plus y. Either take this way, this is taken by from Q to C, or Q has 6 units, or Q has 6 units, out of which 5 minus x is given to store A, and 5 minus y is given to store B. Either take this or take this. Whatever is easy for you, you can take. So what are the conditions coming? From first one, x should be positive. Now can't be the number of products can't be negative. So x and y both should be positive. First conditions are coming from here to here, here and here. Second, 5 minus x should be positive. 5 minus y should be positive. And third is 8 minus x plus y. This should be positive, and here it will come 4 minus 8. So this will be minus 4 plus x plus y. This should be positive. So here it is coming xy plus y will go this side. So x plus y less than equal to 8. And here it is x plus y will go this side. So x plus y is less than equal to minus 4. So what are the conditions coming? X is positive, y is positive. 5 is greater than equal to x, or x is less than equal to 5, or y is less than equal to 5. And here the conditions are this is for your linear equations to plot. Then how to frame the z objective function. Now transportation per unit is given as below. 160 units are supplied to the cost in rupees. 160 rupees is this supplied to this. It says the cost of transportation per unit is 60 rupees. So how many are supplied? 160 now. So z is equal to 160 into x. That is from P to A we have supplied. Then P to B is y. So that is 100 into y. Then P to C is 8 minus x plus y, and that is 150. So 150 into 8 minus x plus y. That much is the total cost for P store. Now for Q store, 100. So 100 into how much is given by Q store? From store Q to A, 5 minus x. No? Then 120, how much is given by store Q to B? 5 minus y. And then 100 into how much is store this store is giving? That is minus 4 plus x plus 1. So this is your objective function for transportation purpose. So that will come 160x plus 1. But solve it. This will give you 160x. Then minus 150x from here. Then minus 100x from here. Then plus 100x from here. This one. So x all terms are taken. Now take y. 100y. This one is taken. Then minus 150y. This one is taken. Then minus 120y. This one is taken. And then plus 100y. This one is taken. Now the constant terms. 150 into 815 is 120. So this is plus 1200. This is taken. Then 100 into 5 plus 500. Then this 600. This 500 is here. This 600 is here. Then minus 400. So this will give you the objective function. The 160, 100 cancel. So this is 160 minus 150, 10x. Here, 200 minus 270 is minus 70 by 100 plus 100, 200 and 2 minus 270. So 200 minus 270 is minus 70 by, and the constant term is 12 plus 5, 17, 17 plus 6, 23, 23 minus 4, 19. 1 by. So that is your z function, right? Here this is coming minus 4 plus x plus y greater than equal to 0. So x plus y is greater than equal to 4. I think we had taken wrong earlier. Right? So this is x plus y greater than equal to 4. This is x plus y less than equal to 8. And from here y less than equal to 5. And x less than equal to 5. And x, y both 4. These are the conditions which you will plot. And objective function is this. Now next question of this same transportation problem. There are two go downs A and B. So write down A this side and B this side. And they supply to D, E, F. So D, E, F. These are the three stops which will take from A and B. But they supply to three rations of D, E, and F, whose requirements are 60, 50, and 40. D requires 60 quintals, E requires 50 quintals, F requires 40. And it produces 100, and this produces 50 quintals, right? So let us again suppose A to D supply is X quintals. So X should be positive. If it is taking X from here, how much it will take from B? 60 minus X. And again take it as positive. Now, if A supply Y quintals to E, how much it will be? E will take from B 50 minus Y, which is again positive. Now, total requirement is 100. X and Y is already taken. This and this is already taken. So, how much is left? 100 minus X plus Y. He needs, that should be again positive. Now, how much this depot will supply B, go down will supply to F. The total requirement is for 40 and this much is taken. So you can say 40 minus 100 minus X plus Y, right? This is now he requires which he will take from go down B. So what can you say? Minus 60 plus X plus Y. That is greater than equal to 60. So X plus Y is greater than 60. One equation is this. From here, 100 greater than equal to X plus Y, or you can say X plus Y less than equal to 100. Second equation you are getting from here. Third, X 60 minus X is greater than 0. So you can say X less than equal to 60. Next, 550 minus Y is greater than equal to 0. So you can say Y is less than equal to 50. So these are the four conditions and then XY quantity. These are your linear equations which you have to plot to get the solution. Now, how to frame the objective function? The cost of transportation per quintal. Now, per quintal is there. So, from A to D, it supplies X units. A to D, it supplies X units. This is X units he supplies and cost is 6. So, 6X. Then, these from A to E is Y. So this is plus 3Y and then to F. To F is 2.5. 2.5 into 100 minus X plus Y, right? That is for A. Now for B. B is giving 60 minus X. So 60 minus X. Then 2 cost is for E. So that is 50 minus Y. And then 3 into minus 60 plus X plus 1. So that is your objective function. Simplify it and find out the objective function Z, which you will minimize. Cost should always be minimum. So you have to minimize this. So this will be 6X minus 2.5X and minus 4X, right? And then 3Y minus 2.5Y and then minus 2y. And there it is plus 3x from there and plus 3y from there. So this is getting 9 minus 6.5. 9 minus 6.5. So that will be 2.5 x. Then 3y plus 3y, 6y minus 4.5. So that will be 1.5y. Now constant term. This will get 250. This is plus 100. Sorry, plus 240. 60 into 4. 240. Then 100. And then minus 180. Right? So this is 240 plus 250. 490, 490, 590, 590 minus 80. 510, 410. So this is coming 400. So this way you can solve. This is how to frame the equations. Now I'll show you. Now I'll show you how to plot this. This is you have taken x-axis. Y-axis, right? Then the equations are, first one was xy positive, that means first quadrant only I have taken. Then was x less than equal to 60 and y less than equal to 50. So I am taking, and the other conditions are x plus y less than equal to 60 and x plus y greater than equal to 60. Okay. So let us take this as 20, 40, 60, 80, 100. This also is 20, 40, 60, 80, 100. Right? So first x plus y is greater than equal to 60. So you know how will you make the table? Once you put x is equal to 0, y is equal to 60, and when y is equal to 0, then x is 60. So if I join this 60 point and 60 point, then you will get that value. So this is your 60 is to 69, right? Then 100 balloon. Then x is less than 60. And y is less than 50. So now, if you put 0 and 0 over here, 0 plus 0 greater than equal to 60, it is away from the origin. So this 60 line is away from the origin, right? And this 101, 0 plus 0. less than equal to 100. True. So this is towards the origin. And then y is less than and x is less than this side. And x plus xy both are positive. So what are the conditions? What is the shaded area I am getting? This one. This one. Shaded area I am getting. Right? So you can find out the points from here. This is one of the point. This is another point. This is another point. One point is this. So at these points, you will find out z. At what is the z coming? Put the values of x and y in that and will maximize or minimize it, right? You know how to maximize, minimize. So what are we getting here is 2.5x. Z is equal to 2.5x plus 1.5y plus 410. In that, you will put this x and y point and check where the value is minimum. So that will be the solution of this, right? So check out the points over here. I think this will be 10 and 50. If this is accurate. Then this is 60, 0. Then this is 60, 40. And this is 50 and 50. So we can find out the points from here, points, and put these values in these z of this is put x and y over here and check which is the minimum value. So this way you can solve it.